So your packet starts with the keywords for each operation, as you can see here. Probably would be a good idea to take a minute to look through that, and then if you want to pause, to just kind of read through what words will be representing addition, what words subtraction, what words multiplication, and what words division. Pause now, take a look at that. Okay, so once you've unpaused yourself and you know the words now, some kind of strategies and some hints, I guess you would say, for setting up word problems is that you want to make sure that you organize the important information you're given. So sometimes we're given like some fluff to the word problem. We don't really need it. So you really want to go through and think about what value needs to be with a variable. So that would be considered a coefficient. What value is by itself, numerical value, so meaning a constant, and then what is the total. That will kind of help you get the problem set up. We're not going to solve these, but I do just want to go through and look at a few of the problems that you have in this packet. If you look at number 1 on the back side of the first page, at a restaurant, jars of tomato sauce are stored in boxes in the pantry. Each box contains 8 jars of tomato sauce. A cook uses 2 jars from one of the boxes. So if you're taking a look at this, it says each box contains 8 jars. Well, we don't know how many boxes there are yet, so that might be something that we're thinking about, that we might have to figure out at some point. And then it goes on to say a cook uses 2 jars. Well, if he's using 2 jars, that means that he's taking away 2 of the jars that are there. Which function shows the relationship between y, the total number of jars and of tomato sauce remaining in the pantry, and x, the number of boxes in the pantry? So since it says each box contains, and we don't know how many boxes there are, we're thinking about the fact that 8 will be the coefficient for x. So just think about that when you're going through. And then the other word that should stick out to you is uses. That just means that it's subtracting those 2 jars. Okay, those would be the important pieces that you would want to pull out. Number 15 looks like it's going to be an inequality just by looking at the answer choices. So number 15 says a grill at a barbecue restaurant will be used to cook sausage links that are 2 pounds each. I'm just going to go ahead and put an arrow here because I see a number. So I'm going to remind myself to go back and look at it. And briskets that are 6 pounds each. All right, so it looks like we're looking at 2 different things, sausage links and then brisket. No more than 120 pounds of sausage links and briskets will be cooked on the grill. So that's just kind of setting you up for that inequality, no more than. Which inequality represents all possible combinations of x, the number of sausage links. So x needs to go with 2. X needs to go with 2. 2 needs to go with x. That will be cooked on the grill. And then y, the number of briskets. So y is going to be going with the 6-pound briskets. And those all need to add up to be no more than. So you're thinking less than or equal to, because it just says no more than. So those would be your keywords in that one. Number 2 is going to be it looks like it's going to be a system because there's 2 equations for each. So let's read through number 2. A drummer and a guitarist each wrote songs for their band. The guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. They wrote a total of 46 songs. Which system of equations models a situation if the drummer wrote D songs and the guitarist wrote G songs? So if you're looking at this, I would just go through. The guitarist wrote 8 fewer. What does this mean, fewer? That's going to mean subtraction, or 8 less than, 8 fewer, subtracting. Then twice the number of songs. Twice right here means you're multiplying by 2. Multiplying by 2. And then you know that both of them added together came up with the 46 songs. So however many songs the guitarist wrote and however many songs the drummer wrote, that's going to total up to be 46 songs. So what you want to be thinking about is that this first sentence, the guitarist wrote 8 fewer than twice the number of songs the drummer wrote. That's going to be one equation. And then the other equation would be the fact that both of them together wrote the 46 songs. So using those 2 sentences, that's going to allow you to set up this system. Okay. On number 33, researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing, so 450 is decreasing at an average rate of 0.06 meters per day. Which function can be used to find the thickness of the ice shelf in meters, X days since the discovery? Okay, so if it's decreasing, you are taking away. That's a subtraction. And it says an average rate of 0.06 meters per day. Well, this word per right here means that you're multiplying. So what you're going to do is you're going to look through and you're going to say, okay, I'm looking for when I'm multiplying 0.06 times x. Well, here's an option. I guess technically here's an option. Here's an option, here's an option. Okay, well that doesn't help us. So let's go through again. If it's decreasing, think to yourself, am I adding or am I taking away? Well, if it's decreasing, you're taking away. Notice here, you're taking away 0.06. Here, you're adding. So the fact that you're adding right here, you can get rid of that. The fact that the 0.06 right here is positive, you could get rid of that. Now, if it tells you that it starts at 450 meters, that's going to be kind of what is your like anchor to choosing between these two. If it starts at 450, well, then you know that the answer choice would have to be A, because that's the one that says it starts at 450. If you distributed this to 450, that would change it up completely. So just kind of breaking apart those words. Okay, we're going to do one more, number 35. The amount of fertilizer in a landscaping company's warehouse decreases at a rate of 3%. This should look familiar to you. This should look familiar to you because you had this on your Unit 9 test. Let's start again. The amount of fertilizer in a landscaping company's warehouse decreases at a rate of 3% per week. Decreases at a rate of 3%. Well, I know I'm thinking about, I need to change that to a decimal. So I'm going to change that percent because I know that's what I need to do. The amount of fertilizer in the warehouse was originally 78,000 cubic yards. So that's our starting value. Which function models the amount of fertilizer in cubic yards left after W weeks? Looking at this, what kind of function is this? That's right, it's going to be an exponential function. Now we know with exponential functions that it's your starting amount. What's our starting amount? 78,000? Okay, well if I look at these options, if my starting amount is the A, 78,000, I can get rid of A, I can get rid of B. So I know 78,000 is my starting, and then it's decreasing at a rate. Well, I know I'm always comparing to 100% or the number 1. If it's decreasing, I'm going to be subtracting 0.03. So then once I do that math, combine it together, that's going to leave me with answer choice C as my option there. So it's important on these set it up problems, even though that they're kind of bigger problems and they look intense, if you can just break it apart, find the numbers, find those key math words, that's going to be what allows you to set it up and be successful in these problems.